In this problem, we have a collision that is initially in one dimension that leads to final velocities in two dimensions. And as before, we have to use the conservation of momentum to be able to solve this problem. So let's start with the momentum initially in the x direction has to equal the momentum final in the x direction. So that's the mass of robot A times the initial velocity in the x direction of robot A plus mass of robot B times initial velocity in the x direction for robot B, and that has to equal robot A mass final velocity in the x direction for robot A plus mass of robot B final velocity in the x direction for robot B. And so we can solve for the final velocity in the x direction for robot B and say that that's mass of robot A initial velocity in the x direction for robot A plus mass of robot B initial velocity in the x direction for robot B minus mass of robot A times final velocity in the x direction of robot A, all of that over the mass of robot B. And if we plug in these values that we are given, we get 20 kilograms times the initial velocity of A was 2 meters per second plus mass of B is 12 kilograms. It was not moving, so that's 0 meters per second, and then minus mass of A was 20 kilograms, and its velocity in the x direction we are given is 1 meters per second, but then we have to take into account it's moving in two directions, so that would be a cosine 30 degrees all over the mass of robot E, which is 12 kilograms, and that gives us a 1.89 meters per second for the velocity in the x direction for robot B. Similarly, we can say the initial velocity in the y direction, the initial momentum in the y direction equals the final momentum in the y direction, which means robot A mass velocity initial y A plus robot B mass initial velocity y B has to equal mass of robot A final velocity in the y direction of robot A plus mass of robot B final velocity in the y direction for robot B. And similarly, we can say final velocity in the y direction for robot B is going to equal mass A initial velocity YA plus mass B initial velocity YB minus a final velocity YA all over mass B. Again, plugging in these values, we have 20 kilograms. The Y direction is 0, right? It wasn't moving in the Y direction. Plus 12 kilograms, robot B was now moving, minus 20 kilograms times 1 meter per second, and now times the sine of 30 degrees, all over 12 kilograms, which gives us a negative 0.83 meters per second. We have vector components, so final velocity for B in magnitude is going to be 1.89 meters per second quantity squared plus a negative 0.83 meters per second quantity squared, which gives us a magnitude of 2.1 meters per second. And now if we want to find the angle at which the second robot B moves with, we have tangent inverse of negative 8.83 meters per second over 1.89 meters per second. Keep in mind this will be in the fourth quadrant, which gives us about a negative 24 degrees of an angle.